Hi guys, okay, so in this video what I'm going to do is get the area of this building here. This is the Jumeirah Beach Hotel. It is beside the Burj Al Arab, which I'm sure you all know. I like this building because it's a nice shape, interesting shape to the building. You may recognize this photo from the homepage of my website. So I'm going to show you actually how I did this, how I got these curves, and hopefully give you ideas for your IA. So as I always say, guys, what I'm about to do is I'm going to get the area of this building, but that's not what you need to do. I mean, you don't have to get the area of this exact building. Maybe you want to get the area of your own building, or you want to get the area of something else. It doesn't have to be a building. Get some, I don't know, some picture or some piece of art that you've done, or some piece of art that you find interesting, or whatever it happens to be. Just have a reason for getting the area. So there's a sample on my website that was a very good IA where he got, and I've mentioned it in one of my other videos as well, he got the area of the front of his school. The school was a nice curved building, and I think his aim was actually to find how much paint he would need to paint the school. So yeah, come up with your own idea, your own interesting aim. But what I'm going to show you here hopefully will be useful. Okay, so let's go. In Geogebra, here I am going to go to Geogebra Classic. Guys, as always, if you do find this useful, can you please like, subscribe, share with your friends, and check out my website in the link below. Okay, where am I? So this is Geogebra Classic. I have a photo already downloaded, ready to go, of the Jumeirah Beach Hotel. I'm just going to drag it in here like this. If you can take your own, I just got this photo from the Pixabay or one of those free image websites, but if you can take your own photo, even better. Okay, so you may have seen me do something similar in my previous lessons, but I'm going to zoom out and scale this photo. So I have learned through very limited research that the height of this building is 105 meters. And another thing, guys, that I always say at the start of my videos is I'm making this video in like hopefully less than 20 minutes. I'm not going to a lot of detail or effort to make it very accurate. You can do that because you've got, I don't know, weeks or months to do it. So you go to a lot more effort than me is what I'm saying. Okay, so one of the first things I like to do, guys, is if I go to the color of this image and bring down the opacity to, I don't know, say 50% or something, I can see the grid through the photo, which is useful if I want to get if I want to scale it. So let's say, I don't know, let's say for example that I want to line up this corner with the bottom of the hotel. I don't know, might be something like that. That's the bottom of the hotel. Again, you will go to a bit more detail than me. That's not quite at the 105 meters, so let's bring it out a bit. Let's do this till we get up to, let's say that's 100 and something like that. Okay, as I say, guys, you go to more effort than me, but there we go. Let's say that's perfectly at 105. Okay, so that is my building. Now I am going to, another nice little thing I like to do, guys, is change if I click this, no, not that. If I click the image and then this, click background image, now it just becomes a background image and it won't move again, which is nice. Again, be careful though, guys, when you do that, because you won't be able to click back on that. Well, I haven't found a way to do it yet, to get back the image. So it's kind of just fixed there forever, which is good. Okay, what's the next thing I'm going to do? Well, well, before I do, guys, the modeling thing with the points that you may have seen me do before, one nice thing to note, let me just take this and put it down here. So one thing I do like to do is with these, and obviously you're probably aware I'm a fan of modeling IAs, but they're good IAs because you can make them unique. I've said before, guys, your IA doesn't have to be original, but it has to be unique. And when I say unique, I mean like you'll see the function I get for this building. No one else will ever have got that exact same function. Because obviously the way I've scaled the photo, there's just the chances of someone doing exactly what I did there at the exact same scale and putting the exact same points is basically zero. Okay, so one thing you could do, guys, is if you could try and get the area in a more kind of crude way like this. Look, those of you who studied AI may be familiar with the trapezium rule. So it's something like this. You can actually get the area by breaking this thing into trapezia. That's not what I wanted to do. Like this. So you actually get a pretty good, I mean, it really wouldn't be a bad estimate by any stretch of the imagination. So you could do this as your kind of first go. And one of the things I really like in modeling IAs is you create a model, reflect on it, and then you go, right, that's fine, but I'd like a better model. And then you do another model, and then you reflect on that. And then you say, well, hang on, I could even make it better if I did this. And that really adds to the whole, it adds to everything, because it adds to the flow of the IA because it's nicely flowing from one section to the next. It adds to the personal engagement because you're actually doing something original and trying something new. It certainly adds to the reflection because you're critically reflecting on your model before starting your next model. Now, obviously, you have to do all this well, and it helps with your maths as well, because the more you can reflect and explain what's going on with your models, the more you can demonstrate a thorough understanding of your mathematics. Anyway, so you can get the area like this, and then say, all right, that's not a bad estimate, but let's try something a little better. Okay, so let's go back to this. Right, so you may have seen me before, guys, do this. I'm going to get points. I'm going to put one here. I'm going to put one here. I'll put one here. I'm just doing every 20 for no particular reason. Okay, let's say there. So what I'm actually going to do is I'm going to do two functions, or like a piecewise function. So the first one from 0 to 120, and then the next one from 120 to, let's say, 270, something like that. But I have to create a list of points, so I create list, list, and then I drag the box over this, and I get a list of points L1, and there's just 4 points there. I think this would be a nice, probably a quadratic would be fine, but let's see what happens. We'll do a polynomial, L1 for list of points. Oh, by the way, I mean, how many of these points you choose, the less you choose, the easier Geogebra will be able to kind of fit a function onto it. But obviously you need enough to actually follow the curve. Now the degree of the polynomial, if I do well, that's 1, that's a straight line, that's obviously not a good fit. 2, that's pretty good, but arguably not good enough. That's better, isn't it? And you can keep going here. Well, actually, he doesn't seem to like a fourth one, but that's probably because I only have these 3 points. But these 4 points. But the cubic is pretty good, as I said, right? So you can reflect on that before starting another model, but certainly I like that, and it's better than the straight lines. Now, what I'm going to do here is, if I can get down here, okay, I'm going to change it to, I'll do comma, and I'll do x is between, let's say, 0 and 120. So 0 x 120. Okay, not bad. So it stops now at 120. Okay, now guys, one thing that I get asked a lot is why, if when you draw this exact same function down here, let me do it right now. So it's minus 0.01, well, it's 0x cubed, if you like, right? 0x cubed minus 0.01 x squared plus 1.56 x plus 1.64. So I get asked this a lot. I get asked, why doesn't this function look like this function when it's the exact same numbers? And the answer is because GeoGebra is only showing you 2 decimal places here. But in reality, it's using a lot more than that. So if you actually click on this, and then this, and then, hang on, I haven't clicked this function yet. So let's click this function here. And then you click this, and the rounding. He says 2 decimal places. So watch these numbers as I change the decimal places. So when I click 3, these change, but the function hasn't changed at all, or the graph of the function hasn't changed at all. Let's do 3 significant figures. So now what happens is this 0.000324 x cubed. So this number is obviously tiny, and when you're down around here, it makes no difference because it's only 1. 1 cubed is 1 times this. It's nothing. But once these numbers become big, like for example 100, when x is 100, you now have 100 cubed, which is a million. So this number becomes really important. So this is actually a nice way to talk about justifying your significant figures, because that's a big thing that they always pick up on, is how many significant figures are you rounding to and why. And this is actually a nice opportunity, and I've had students do this. They actually put in 2 photos. They put in, well, 1 photo with 2 curves, and they say, well, when I use 1 significant figure, this happens. When I use 2 significant figures, this happens. And you can actually go, you basically want to use the least amount of significant figures where it's still very accurate. So if you did, okay, that's 3 significant figures. Obviously 5 would be even more, but yeah, you could draw a bit like I did with this orange function. I don't want to go through them all, but try the different significant figures and make sure that your curve fits quite nicely on this here. Okay, let me just close that, and I'm going to get rid of this. Okay, next thing I want to do is let's add in some more points. So I'm going to put a point now. I'm going to start up here. Well, not there. Let's start, let's say here. And then we go to, let's say here. Let's go like approximately every 20, down to here, down to here. How far do I want to go? Well, actually, let me do, because here I did every 40, so let's stick with every 40. So 120 down to 160, down to 200, down to 240, and I guess I could maybe go one more. I'll just stop there. Okay, now this function I think looks a bit more like an exponential function. Now you can again talk about these and justify why you're using these functions, but I think this an exponential would fit quite nicely there. So I need to make another list. So I'll do this, and I will just make sure I don't get the F there. Note it hasn't included G, so I can just add G myself. Just add G. Okay. Now let's do fit. I'm going to try. This is an exponential function, and now L2. Okay, that's a pretty good fit. You can actually, guys, move these points around till you get the kind of fit that you want. So maybe move him down a bit. Not bad. Again, guys, you got a more effort than me to get a good fit and justify and explain everything you're doing. Okay, I'm going to stop about there. Okay, now I am going to do the same thing. I'm going to go from 120 to, let's say to 270. Again, it doesn't really matter, guys. You go to more effort than me. There we go. So now we have two functions. Nice. Models this models nicely the Jumeirah Beach Hotel. Okay, now I'm going to let me take a screenshot of this. Take a screenshot of this whole thing. Okay, so here we have it. Now, how do I get the area of this whole thing? Well, if you've studied calculus, guys, it's quite straightforward. It's integration. If you haven't studied calculus, it's not straightforward at all. You need to learn integral calculus, which is not easy, but you will be doing it for sure. So you basically, whichever course you're doing, you're going to be doing this. So you're going to integrate this function from, well, let me write it out, the area. So the area will actually equal the integral from 0 to 120 of this function here. Now again, note the significant figures, guys. I'm going to go 0.0000324 x cubed minus 0.0106 x squared plus 1.56. Now I've actually lost the rest of this function. Let's see what it is. 1 second. I can do this. Okay, 1.56x plus 1.64. 1.56x plus 1.64. So it's the integral of this dx plus, and you can break it into two areas, like this might be area 1. You can define all this properly, guys. And then it will be plus the integral from 120 to 270 of the next one, which is 550 e to the minus 0.0142x dx. That's it. Now, I'm going to use Desmos, guys. I always use Geogebra more than Desmos, but for just very basic calculations and basic graphs, actually Desmos is quite nicer. I actually prefer it. So the integral from 0 to 120 of 0.0000324x cubed minus 0.0106x squared plus 1.56x plus 1.64. Now, a question I get asked, guys, I get asked a lot of questions, as you can imagine. A question I do get asked a lot is, should I actually show the working? And there's a bit of debate amongst teachers and examiners as to what you should show, but my answer would be definitely show. If you can integrate this, yeah, integrate it. Show the examiner, show your teacher that you know that you have a good understanding of integration and you know how to integrate that. That's something you've learned in class. So for me, it would be crazy not to show that if you can. If it's a really complicated function or a function that actually that you can't integrate analytically, and there are plenty of those functions, then yeah, obviously just don't do it. And you can say I'm not going to do it, or I don't want, I'm not able to do it, or this is not possible to integrate, so I'm going to use my calculator. That's absolutely fine. But I would definitely argue if you know how to integrate that, and you should, that's certainly if you're doing anything other than applications SL, you should be able to integrate that without a calculator. And and actually, sorry, even applications AI, you should be able to integrate that without a calculator. But this one, except for applications AI, you should also be able to integrate that. So yeah, for sure, go for it. Integrate it, sub in the values, show all that, and that will help with your understanding. Anyway, the first integral is 7,002. So that means that, and again, guys, my model is very basic. I've just thrown it together in however many minutes this has taken me, but you will do it a lot better. But let's say it's around 7,000 meters squared. And have a think. Does that make sense? Well, it's a big hotel, 7,000 meters squared. It doesn't seem unreasonable if the height is around a 100. 100 times 70 would be 7,000, so that seems all right. But let's add that to the integral from 120 to 270, 550 e to the power of negative 0.0142x dx. Okay, again, that seems reasonable that it would be nearly the same. So 7,000 plus 6,200 is approximately 13,200 meters squared. So great, there you go. That's the area of the front of the Jumeirah Beach Hotel. Now obviously there's a back and there's this thing in the middle, and whatever you want to do, and for whatever reason you're doing it, but there you go. That's the area found. Okay, guys, that's it. That is all I can think about saying. If you have any questions, please ask in the comments below. I'm always happy to answer. And if there's anything you'd actually like me to do a video on that I haven't done yet, about anything, but obviously IB maths related, but doesn't have to be about the IA. Just let me know. Thanks for watching, guys, and I'll see you in the next video.